Okay. Today we are joined by Tuna from Vector Metrology based in Turkey. On today's webinar, he is going to be taking us through a automated workflow for the inspection of sheet metal parts. This workflow, although being shown on sheet metal parts, is very relevant to any parts that are being produced at high volume. A little bit of housekeeping before we start. On the GoToWebinar control panel, you can see at the bottom there is a chat box. So a chat box and a question box. If you have any questions throughout the webinar, please feel free to drop them in there and we will answer them right at the end. So without further ado, I'll pass over to you, Tune.
Okay, thank you very much. And it's good to be here. Let's get started with our presentation. I just adjust my screen. Okay. Today, we are going to talk about automated workflows for sheet metal parts. And thanks for the option. We make a different presentation to scientific look to our system. Let's say we have a problem for sheet metal parts and we create a tools. How can we solve this problem? And the final is the result. We can make these tools so useful to get results better. So what's our problem? Let's talk about first. What challenge are you trying to solve? Our challenge is to minimize the time spent in part inspection of companies with high production volume. It would be hard to an inspector to measure or inspect all the parts with traditional methods, and it takes time. So we have a solution for the something like this high volume productions. There is automated workflows in Control X. With using the batch process, you can easily inspect lots of parts with just one click. And the other things, of course, it is not the only thing. We also offer the best solution for technical drawing requirements. So we never also the one inspection in the technical drawing, like just linear dimensions or radial dimensions or angular dimensions. We have also encountered with the datum target alignments, also GD&T inspections and profile, and line profile tolerances. So we need a solution for these kind of challenges. We have a different tools in Control X to solve this. What are tools we're gonna use? In Control X, it's actually also our workflow for the Control X. We first are practice the sheet metal. So it's usually as an alignment with RPS. So they have the XYZ datum target points, and we need to align with using these points. So the first the topic of our webinar is the RPS alignment. It using CMCML points and the geometric features. Also, with using these features and creating the alignment, we can inspect easily 3D compare and the boundary deviation. Especially in sheet metal forms, boundary deviation is very important to us to check the boundaries of the part. Is it big or is it small or is it deviated? We can see easily in Control X. Also, the other topic of our webinar is the dimensional and GD&T inspection. As we said before, it is not only thing to create only linear dimensions, we also need to inspect a GD&T inspection in Control X. And the last thing we can do, generate report to make a good report for our customers or to us. And the most important topic, also our main topic, is the batch process. It is our time reduction feature in the Control X. So after use these tools, we get the result of the part. We will create in the last part, we create a the program with the automatic inspection in Control X according to technical drawing requirements. And with the batch process feature in the automation tab, we will able to process multiple points clouds to create reports. So let's get started with the first topic in our presentation, the problem. The problem is the reducing time for multiple part inspection. As we said before, minimizing the time spent in part inspection for high volume productions companies, that's our guest parts. As you can see, is the B pillar of a car. It's a middle pillar of the car. It's a sheet metal part. And we can actually, if we don't have the scanning or the any other devices which creates the point clouds, we have to inspect this part with using traditional methods like calipers or gauges, something like that. So you need to check all the dimensions with using caliper, go gauge or no go gauge. And the inspector need to write on the value of these inspections to their tables with using a pen or it may be with Excel. But it takes time. So we need to create a solution to reduce the inspector's time. Let's say if we have 1.9 parts in sheet metal, it's actually the same time to creating an offline program and checking with the calipers and the gauges. But if we have multiple parts, it is the now we need to know this. If there is lots of parts we need to inspect, we don't need to do another offline program in the Geomagic Control X. We need to just one program for the part, and we can easily inspect all the production using the same offline program with using batch process feature. So this is the not only today. It's also we need to create the solution for technical drawing requirements. Technical drawing requirements first for sheet metal could be RPS alignment. As we talked before, there could be an X, Y, Z points for the met parts to inspect with using these alignments. So we have the positions they given from the customer you work for, and it says the X, Y, X2, and X3. It is the positions, position X, position Y, position Z is shown on the table. So I need to create like with using these points. And it says that according to your alignment, I need to check the profile of tolerance for the surface with 0.5 millimeter. Also, I need to check the boundaries of the part with using your alignment. So if there is no scanning your hands, you need to create a gauge or texture to check the points of the surface profile, but it could be just 1 point or 2 points. With using scanning, if something in Control X, you can easily check all points of the part. So you can easily decide it is the defect on the part form or the whole locations. You can easily see and take action about this. So it is not only thing to RPS alignment in our technical drawing, it's also wants to check or inspect the all locations of the part. Like in this one, I can't share with you to a partial or credential of the technical drawing. So I just create the arrows to show what we are going to inspect. And it's according to alignment, position tolerance will be there 0.3 millimeter for these slots or the whole locations. We can also check for these features with using the Control X. And of course, there is untraditional dimensions in our technical drawing. It is the linear dimensions, but we can sometimes see on the notch part of the technical drawing, it could be say it must be measured using the general tolerance table for specific dimensions. In this example, we are going to use the ISO standards and it's using the medium standard for this part. So let's get back to our Control X and try these features in Control X. But first, I want to show you the workflow of the Control X, what we are going to do. The first thing first, we're going to do an RPS alignment with using CMM points and the geometric features from our program. And also we, of course, take the locations of the points from the technical drawing. And the other part of the, we're gonna inspect the 3D compare and the boundary deviation. We check the dimensional and GD&T positions of the holes and generate forms. And after that, we're going to do an each process. Also, we're going to do a offline programming and using for each process to create an automatic workflow for our parts. Let's get back to Control X to show how can we do that. First, we need to import our CAD model, import, and find CAD model. So the Control X is a very useful tool as it is. So that when you just your cursor from any face of the part, you can see the name of the face, like this one is cylinder. Also, when you came another face, you can see this plane. It is it's a very good tool for Control X. It is automatically paired with the point cloud with using these faces. But sometimes we want to change the faces with the different geometries. Like I don't want to use this face as a cylinder. I need to use this face as a plane or anything else. You can change it with your properties section. I just move this to here. Just click the control button and select the spaces which you want to change. Then go to properties section. And in this section, you'll see the geometry type and easily change the which geometry you want to use. Like I want to use these faces as a plane. So I changed it. And after this changes, I can import our first part to create the offline program. Let's import the first point cloud, our parts. And the first thing first, we need to align as an initial alignment we're going to use. And the program is easily recognize the position of the CAD model and the laser scanning, and it's merged it together. So after this alignment, Control can now find the measured and nominal volumes in CAD model. As you can see, I just move my cursor to plane, and it is also as a measured one. So I don't need to create any geometries to measure the opposite component. It's just easily automatically paired the measured parts. So after the alignments, I need to go to check my technical drawing. And it says I need to do this alignment to check profile tolerance and boundary tolerance. So if there is a two different ways you can do this. The first thing is you can easily write these values to simulate CMM point with using the reference position, this one. Also, if you want, if there is an Excel or the text file you have, like I have one, you can copy these tabs and create a new text document and copy as an main X, Y, Z axis, and then save it. You can also import these points with using the method from file, select file. Where is our file? Open, and you need to say which one is represents which value, like X, Y, X2, and X3 is represent what, and let's select name X, Y, and Z. Then we say, okay, now the program is just put the nominal value of there. And also if we check the search reference position by connected, it's easily recognize the position of the simulated CMM point to cat model, and also pair it with automatically the measured value. Then click OK, and Control X created the 3 simulated CMM points with their names. So as we said, when we created 3 similar CMM point, but also we need to create the circle and the slot. Let's look at it, and there is shown in the below, shown in the picture, there is a hole using Y1 and Z1, and the slot is using as a E2 axis and reference target as a reference target. So you need to go to RPS alignment and check the X1 point and which axis you need to use. The other axis, just check the V1 to use the specific direction point. After doing this, I need to use this hole as a Y and the Z axis to do my alignment. But as we talked before, I don't need to create them a circle because Control X easily recognize the geometry of the part and just automatically pair the measured one. So I just click the cat model face, and it's also automatically paired with the measured value. And I select the correct constraints. And the last one, when I cursor on the boundaries of the face, it is recognized the position of the certain slots and just click it. Then I change the settings of this slot's direction. After this alignment, I just check OK. Then Ctrl X is completed the alignment. The other thing is we need to do to share this whole picture in our report. You can set or adjust the labels whenever you want to take a photo. Click RPS alignments with using the port camera. You can easily take a photo for your report. So after the alignment, let's get back to our requirements. We need to check the profile tolerance on the surface. I just click the 3D coin pair. And the next stage, you can specify the tolerance with using this box. I say 0.5. And the maximum minimum range also, it is given. You can change your projection direction with using this. I like to use along normal. As you can see, on the part, it's also colored to see the defects of the part when you see the different from the green color. And after this operation, check OK, and Control X, inspect the profile of the part. I hide the points of the RPS alignment, and the 3D compare, I just click to take a photo of motion to report it using port camera. And I need to check the deviated points on the part to see the deviation of the surface. I just select the comparison point. You can use 2 different, I want to show you 2 different ways to take points. One is you can use the peak points, just click on the surface to take points. Or if you have a spline like this on the part, you can use the long curve method to get a point with the homogeneous pattern. I just need to select the seat position, start with this point, and also select to head curve with using the spline of the part. I just select. Then you need to adjust the options according to your technical drawing. We have the specified tolerance with 0.5, and I need to take 2 points and also the equal spacing. So I just check this box and change the direction to our points, then just click OK. It creates the equal spaced points to on our parts with using the comparison point. You can adjust the labels with just move, click and move. Then you can select the CMP1 and using the torch camera, you can take the photos on the CMP1. After that, we can also do the same thing on the different face on parts along the curve. As curve, first you have to select seat position and the path curve. Then you need to adjust the points of the parts and equal space. As you can see, it is not take points from this supply. It could be sometimes. This is the why. It is the reason. If there is another supply to different part, you need to merge of the supplies. So I just click the path curve and select these two, and then the Control X recognize both supplies and just equal spaced 10 points, and okay. I just recognize that I didn't adjust the tolerance zone. So if there is something like problem you encounter, you can easily change it. Double click on the feature, and then using the same box as before, you can change anytime you want. I adjust the labels, then click the CMP2. With using the fourth camera, we have the surface tolerance is done. So the other inspection we need to inspect, it is good according to alignment, boundary tolerance will be at 0.5 millimeter. So if your part is a surface body, you can check the boundary deviation easily. If you have the solid body part, you need to translate it to surface body to check this feature. So we have a sheet metal part, and we take this CAD model as a surface body and just using the boundary deviation, when you just move the cursor through boundary, close to boundary, it recognizes the supply and you can select it. You need to adjust your measurement because we want to do measurement with using tangent direction. If it is not checked, your deviation inspection will be deviated according to your parts form deviation. I just want to see the boundary deviation. That's it. And you can need to check the tangent direction. Also, projection direction is along normal and the next stage. The same color bar options, all the features, you can easily change it. And there is also two ways to do this. You can click on the supply, or you can use the along curve as we used before, like seat position somewhere on the part, and it's how many points you want to take. You can write in there, and also it's a full spacing. And you click the apply, all points appears on the secret. After they apply our feature completely, we have the parts inspected from the boundary deviation. So the last thing we need to do is select the boundary deviation feature and using with the fourth camera, we take the photo for our report section. So this is our profile and the boundary inspection according to our alignment. But it is not the only thing. If you also want to check the position tolerance of the part, you can also do this with using the dimension stuff. I just hide the features and then create a book to inspect the bones slopes or rectangle slopes position with using group. We have a position feature in the dimension tab. You need to create, it's your choice. If you want to create a construct geometry, you can create to a constraint plane. Like I don't want to use this plane. I want to project this rectangular circle to this plane, something like that. You can do this with using construct geometry like rectangle. I just select the rectangle spline and say the project on plane, which plane you want. If this is the plane you want to use, just click it and then, okay, you can easily do this. If you also create this construct geometry, you can easily inspect the position of the rectangles to is directional, not in GD&T only. We also see this feature after we using this methods. I created the awesome circles and the slopes. When I just connect the boundary of the slot, it recognizes and it's creating the slot. And that's it. So I need to check the position tolerance. As you know, it's a GD&T inspection. So when I select the rectangle and put it on the screen anywhere you want, there is a three different options you can use. First one is the bottom reference frame. If you just checked what there is non-bottom, it can be inspection inside. Like when you select two different geometries with using the use data reference, it checks the inspection as a pattern inspection. If it is the use current alignment is checked, so the position inspection will be according to our alignment, like position, rectangle, use current alignment, and it's checked from our alignment according to our alignment. So if you don't use the apply button, you can easily create all the positions for the geometric features one by one, like using this. And when the job is done, you can easily apply the feature. After creating these positions, I check the drawing and I see I forgot to change the tolerance of the inspected locations is a 0.1, but it must be 0.3. So how I can change the value of tolerances? I need to double click all the and the 0.3. It is not a necessary thing actually. You can easily select it using CTRL button, control button, and select all the labels of the parts and then go to properties and write 0.3 tool box. And it's all changed automatically. It's a most common question when I giving a training. You can easily change all the tolerances with using property stuff. So after this inspection, also you can take a photo from the clicking to group 1 with the fourth camera. You can take the photo. And we came to last stage of the inspection. It is the linear dimension of the part with using the reference or reference circle and the inspection of the linear dimensions into the other geometric features. But it says it must be tolerance with using the ISO standards. So in Control X, you actually have a standard tab to use ISO standard where you can reach this setting menu, file, metrology tab, click, and this tab you can select the tolerance and you can easily select which tolerance you want to use. It's fine or medium or coarse. You can easily select in this tab and then apply. Okay. Now when I inspect the linear dimension, it takes the tolerance from the ISO standards. Like these two. And you can change the alignments, which axis you want. Like I want to inspect in the axis. Label is on C. You can rotate it using this more options button. Also, let's check the other dimensions. You can also use the control space button to back to use same feature on the top without clicking. Data alignment tab. As you can see, I don't need to create the geometry to check this linear dimensions. I just click the boundaries of the parts to check it. It's an easier way to inspect your parts. And the last thing also is circle. And last inspection to our parts. And that's it. I just inspect all the linear dimensions of the part. And as you can see, according to the nominal value, just get tolerance from the ISO standards. So forward, the last thing we need to do is, as always, click the group 2 and with the third camera, take the picture for the report. So we just create our offline program, and the last thing we need to do is creating or generating a report. For generate report, we can select template as one of yours. You can customize according to your needs. I just check our company's template and I select the entities I like to show our reports. Like I need to show the RPS alignments, compares, and the groups. Then I can just write down the properties of the part in the section, whatever you want to write about the parts. I just check this. And then when you click to generate, a Control X easily creates a report. Here for the expected part now. There is a 3 different options you can save as. It is could be a PDF, could be an PowerPoint or Excel. Which one you want, just click the symbol of the part and then write the name of the report, like a pillar. And no one. So we have the fully completed offline program. We can save our program to anywhere we want as a template. And let's get back to our presentation. So we create the program offline program, but we need to reduce the time now. So as we can see, we created a program ready for the automatic inspection in Control X according to our technical drawing. But now we need to inspect also this part like part difference. So let's say if we do this in Control X and traditional method, in the first piece, as you can see, I spent the time to create a offline program. Like it takes 20 minutes. But also we can say that if we inspect this with using calipers or gauges, it also takes 20 minutes. But after this part, I have now fully completed the program. So I don't need to spend much more time like 20 minutes in this part. It's just I need to select the point class and using the batch process, it can easily giving us report. Let's get back to our Control X and try it. I just clicked Automation tab and using the batch process, I need to add the files which I want to inspect. Add files, select the five of the files, all of them, open, and you need to do just some settings in here. The first thing first is when you want to save the model file. It's some Control X project file. If you want to check some of the parts in individual, so you can check this button to create and save the model files also anywhere you want. But in this section, I just want to need a report. So I just check the export report and it says which kind of type you want to save as. So I just check as a PDF. And I like to show you also if there is a 5 or more parts you need to inspect of the same production, you can also inspect the statistical process control with using XML file and the Geomagic Control X thread analysis feature. I just check it. Then I just select the output destination file, user deployed folder I need to set, just click and the file is set. And after that, you need to choose the name of the report to understand which one is what. So I just select the niche file group. So my reports taken names from the point clouds name. So the node 1, node 2, node 3, someone like that. So when I click to OK, the program starts with the inspection with the first part of our webinar. Let's get back to see our file. Now it starts with the calculation. And the destination of the part is Japan. Let's check for all the parts. As you can see, it is also already completed the first parts of our webinar. Also, it's completed the second part. You can look at the report. If it is still inspected the other part, you can just double click the report and check the parts of the geometric shapes. It took time, and you can see the time of the first part is 2:39, and third part is completed at 2:30, 2:40. I like to show you how much time it takes. So I created 5 different parts for this inspection. And the last part also has been completing. So when we look after our table, as I say, it takes 20 minutes to one piece to create a fully complete automated offline program, but it takes 5 minutes to inspect the second part. But as you can see, for this part, it takes much lesser time. It's like in 1 minute to inspect the 5 parts. So it's actually our time is much reducing than we expect. So after this inspection, I need to check the statistical process for this all of these parts. I can just go to Tools tab and use the trend report. And after this, you can import the source report. I have already saved as an XML file this 5 of them. I select them, open, and the program creates an SPC template for us to choose which one we want to inspect as an SPC. So it takes all the inspections we already done, and you can just click the generate and select the points which you want to take an SPC report. Like I want to do CMP 1, 5, and 10. I can just uncheck the other points of the parts. And then after this, you can click again generate to create your SPC report. We will see for these points 5 different parts, and we can also decide to which part is the biggest defects or which one is good. And our SPC report is ready. When we get back to CMP11, and we can see the number 1 is the out of tolerance value is 0.8, and it is not in the tolerance area, but the other 4 part is in the tolerance area. So let's keep looking this part 1 to other pages. It's also out of tolerance. Now it's an intolerance, so also in CMP2, so not a tolerance. So I decide which part is a biggest defect. Also, I can see our 5 difference, but it's automatically calculated CPK value to use our production lines stability. So if you want also, you can create as a PDF, PowerPoint, an example, select PDF as an SPC report. It's also saved as a SPC report. You can change its names if you want. Now, we have a conclusion for this section of our presentation. Now we have a time difference between traditional and the geometric control. But there is a problem. Our first piece of our parts, there is an ambiguous defect on it. So what is the reason for it? Can we find the reason? Yes, actually we can find. Let's get back to scientific table of ours. First, we need to describe the problem, which tools we can use, and how can we get the result. First, what is our problem? To identify the source of the part defect and deciding on necessary corrective action. So our defect is due to the whole sentence, or our form is defective, or piece 1. For these questions, we have tools in Control X to use a result data and the result navigator. Result data and result navigator is a powerful tool to compare different alignments to see the reason for piece 1's defects. So we aligned our parts with using the target points. but we can also align our parts with using formal part. So with these different alignments, we can compare with each other to see the difference of the inspections to decide it is defects according to a due to the whole center or the form. So after we do this, we can perform different events with result data, and we can compare those alignments. Let's get back to our Control X now. As you can see, with our measured the data is no by, so we can want to get back to know one. So if you have only one part, you have a template. You can use this template with just one part. You don't need to use this program with 5 or more parts. It is not a necessary thing. You can just click replace measured data, select number 1, and run inspect process. It's also gave us to inspection of the number 1. It's completed the inspection, also created the inspected all the parts of number 1. So as we talked before, let's assign back to apply the viewpoint of the 3D compare. We can see the variation of the part on the form in here, but our alignment is RPS alignment. So let's write the result from 1 and rename it as an RPS alignment. And let's this result to duplicate. It's using the duplicate, you don't do exactly the same page of this inspection process. So you can change all the specific areas of this program. So you can just click RPS alignment and delete one. After that, you can use the best fit to see form alignment. How can we? Yes. After your basic alignment is done, now you can see that your form is on in tolerance. So we can say, yes, when we align with the using surface of the body, it is in tolerance, but with using the whole center, it is out of tolerance. So I need to compare these two to make a decide which is the problem. Let's say best fit. Then I need to compare this one. You can just come back to tools and use the result navigator to see and compare the RPS alignment and the best alignment. So when you see these two sequences, you can which one is what. You can see the result best fit is for this sequence, like also RPS is for this. Yeah, I can see now the best alignment is much better for the form inspection. However, it is better for the boundary or the position of the circles, or it's getting worse. I need to check that. So first, I need to also report it to our administrator to, if we align with the partner with surface, it is much better for the form. I need to just click the first camera on the screen to get an photo. And after that, you can change the display state with just clicking this area. I just want to check the boundary or also this click. And the group 1 to see. I just need to show all of them. Also press align wheels. Comparisons. Yes, when we use the best alignment, it's also good for the position of the circles. And also you can take the photo with using first camera on the screen. Now we have the different data on our program. We can generate a report with using these photos and tables. So to take a report, let's get back to home, generate report, and you can now select the results according to your names. I just select our template from the RPS alignment. I want to just show the 3D compare and the group one. Also, with using the best fit alignment, I need to show the 3D compare and the locations of the home. If you want also, you can add the result navigator compare pictures. You can select the views and just drag the button to add to your report. After that, you can also write your properties on this top and just select to generate. It creates a report for us, and it is also adds the best fits pictures and RPS pictures on the same report. To decide which one is the RPS, which one is the best fit, you can check the header of the page. You can see that this one is RPS alignment and this one is best fit alignment. To shrink and to complete the page, you can easily select the right and just click and drag to make more meaningful report. It's also a location of the parts and the last thing for this one. As you can see, the customs also in here and the here. So we can already decide the problem is defect is the reason of the whole centers. With using the Geomagic Control X, result navigator and result data, you can easily check different alignments and compare each other to decide our part defect. Thank you very much for listening to me. If there's any question from you, you can easily write down the chat box to get answered. Thank you very much.
Thank you, Tuna. That was great. It looks like we have a couple of questions here. Can we rotate the annotations?
Of course, let's get back to Control X and how can we rotate? So as like see this, the annotations sometimes rotate like this. You can rotate using two different ways. First one is double click on the label and using this button to change the rotate. And also if you want to change the annotation view, you can just name here menu, file, metrology, annotation tab, and you can change the alignment tab ISO to horizontal and apply. You can see all the labels in the screen.
Great. Another one here around automation. Can you use an automated program for single parts?
Yeah, that's a very good question. It's not necessary to create the offline program for just multiple parts. You can use automation table and batch process just one single part. Add files, just select which file you want to use and just click OK. If there is more than one result data, it's asked you to, it's also replaced down to. If you say yes, you can create a report with using both of the result attacks, I just click yes. Easily, it can inspect the one part of our program. Thank you for the question.
Great. I think we've probably got time for one more question. Can we inspect the whole deviation as XYZ?
Well, okay. It's also in Turkish questions. We have, yes, it's actually when we see the RPS position inspection, we just want to see the, I just adjust the viewpoint, yes. So as you can see, you can just get the measured value. There is no deviation as an X, Y, Z. If you want to see which direction this whole center deviated, you can easily select the geometric feature on the top, like the circle one, and click the right button, preset, and you can say detailed. You can easily see your whole center is deviated to which direction with using this label.
Great. All right. I think that is all we've got time for. Thank you, everyone, for joining. Thank you for presenting.
Thank you very much.
If you have any other questions after the webinar, then feel free to reach out, and we'll be in contact to answer them. Appreciate your time and have a good rest of your day.
It's all good to be here. Thank you very much.
Thank you.